Hey guys, we're going to talk about, we're still in section 4.2, graphing polynomial functions, and we're going to talk about the intermediate value theorem. And whenever you talk about theorems and they write it out as theorems, it's important to actually go over that and conceptualize what is this actually telling me. And if you can really piece through it, you understand. Oftentimes it's an epiphany. You're like, oh, I know that. I see that whenever I work problems. I hadn't really thought of it that way. So we're going to go through the theorems in this course. And this is one of them that it can be one of those epiphanies whenever you look at it. Sometimes you realize it subconsciously and just don't piece it through. So the intermediate value theorem. Polynomial functions are continuous, meaning there's no breaks in their graph, like a piecewise function to where you can have something like this and it comes across and then it has the open circle and then somewhere else it has the closed circle goes across, and then you can have also uh, the hyperbolas to where you have asymptotes in there. You have graphs like that to where a certain value can't be. Okay. Polynomials are continuous. This goes on forever, all the way through. And this goes on forever, all the way through. Same here. And how you know they're continuous is that the domain is from negative infinity to positive infinity. Or else we'll say all real numbers. This symbol here, this R, looks a little different. That is the symbol for real numbers. So what the intermediate value theorem says is that for any polynomial function, and we'll call it p of x, suppose that for a does not equal b, and these are just x values right here. A of p and b of p are of opposite signs. Then the function has at least one real zero. So at least one real zero between a and b. So let's look at it on a graph. So what I'm saying is that I'm going to have two x values, and I will call one a and one b. Those are your x values. As long as they're not equal to each other, the 2 points that they create, so here's the x value listed as a, and this is the y value listed as p of a. That gives me the point a comma p of a. And this is my second x value. I'll call it b, and that gives me the point, that's the x value, so this is the y value, p of b gives me the point b comma p of b. If the value for p of a is positive or negative, and the value for p of b is the opposite, so negative or positive, then there is at least one real zero in between them, and we'll call that value of x c. X is your independent, your input. What you put into your function, you're going to get something out, and that is your y, or written in function notation, p of x, here p of b, or p of x, here written p of a. This is y will determine the sign at that point. Up here I have it written, and you'll see this often, to where instead of just saying positive, they're going to say the y value has to be greater than 0 and the y value has to be less than 0. You need opposite signs between your y values within that interval to indicate that there is a 0 that occurs, which should make sense if we're graphing. If we're going along and we're graphing, and I get to here, and this value of x has a positive answer, and then later I get to here, and this value of x has a negative answer, somewhere between those, because it is continuous with no breaks, it has to cross the x-axis. An intersection of the x-axis, we call it an x-intercept, but we also know it as the zeros of the function, the roots, and that is the intermediate value theorem. So let's take a look at it to make sure that we do understand exactly what it's giving us. Okay, so graphing polynomial functions intermediate value theorem. What does the intermediate value theorem mean? What it means is if you select, or in your homework problems given, two values of x, so, and you could simply, we're going to call them a and b in here, but this is how to look. It could be like f of 3 and let's say f of 5, or it could just simply say let x equals 3 or x equals 5. Okay, but you most likely be given two values. For what we're doing, we'll call them a and b. Then what you do is you plug the values into the polynomial to find the corresponding y values, f of a and f of b. If f of a and f of b have different signs, so plus or minus, then the polynomial has crossed the x-axis. This means that there's a zero or an x-intercept between those 2 points, a and b. And for our theorem, we just call it c. That value is p of c, which is equal to 0. This is an actual 0. All right. What we also need to make sure that we know is if f of a and f of b have the same signs, this does not mean there is not a 0 between the x-intercept. And look at this, what I've drawn is that f of a was, and this is f of a, this point here, and this is f of b. In between there, I have 4 intercepts going on. Even if I pick two numbers that say a was 1 and b was 2, I can still have intercepts that occur in between them. So it doesn't completely negate the fact that there are some zeros in between those points. Alright, let us look at an example. We're going to use the intermediate value theorem to determine, if it's possible, whether the function has at least one real zero between a and b, and they give me values for a and b. So how to solve? I just plug it in. So 120, -5, -18. Okay, so I have a negative sign here. This one here is negative. Okay, and f of a -4. And then 70, so 7. And this one's positive. So what does this tell me? This tells me at least one real 0. Could be more, but I know there's at least one because on that I have somehow crossed the x-axis like I showed on the graph. Okay, I've crossed the x-axis with what I'm doing. That's a horrible diagram. I apologize. Okay, and then something I didn't touch on, anytime you have a negative number to an odd exponent, it's going to be negative. Anytime you have a negative number to an even exponent, it's going to be positive. Okay. So that's 50. Positive. So I need to get a negative if I can say something, otherwise I can't. So a negative 2 to the fourth minus 15. And it is also positive. So I can't rule that out because I could have a 0 at 2 point, couple zeros between 2.5, and then they both end up being positive after it crosses the x-axis. And let me do a better diagram of this one. What I'm saying here is if this is a negative 3 and this is a negative 2, I can't determine that there's 1, but what I could say is that there's 2. It could come down something like this, and it ends up that both of them are positive. Okay, so I could have one at a negative 2.75 and at negative 2.25, something like that. I just know that there's not 1. Okay, so I cannot say that a real number exists, one real number 0 exists between those 2 points. Alright guys, that was the intermediate value theorem. Please watch the publisher's videos, structure and critically think about your homework. Each thing that we're doing is tying in each time. So whenever you work your homework problem, work it again and again and again to make sure that you fully understand it, and only you know that you fully understand it. And good luck with your homework.